So let's get a meeting started with Arnold and the Sky This Month.
Well, thank you, Paul, and hello, everyone near and far. I'm speaking to you from my home in Whitby, Ontario, the traditional territory of Great Mississauga Nations, a subgroup of the Ojibwe Nation. Now, the stars of the familiar Orion constellation represents Bibukeonini, the winter maker to the Ojibwe. His arms reach as far west as Aldebaran in Taurus and east to Canis Minor, ensuring that some part of him is in the sky when we feel his cold breath. The Ojibwe tell us that Bibukeonini was maddened by a duck who paid no attention to his efforts to freeze him out, and he continued to break through the ice to catch fish. The winter maker eventually gave up and retreated north, where it is always cold. The duck teaches us to ignore the cold. Go outside and have some fun. This will madden the winter maker and chase him away whenever he does pay us a visit. Visit nativeskywatchers.com to learn more about the sky lore of the First Nations people and read the stories involving their constellations. Now, the highlights for December includes 4 close passes of planets with the moon: Venus on the 9th, Saturn on the 17th, Neptune extremely close to a first quarter moon on the 19th, and Jupiter on the 22nd. The moon drifts by the Pleiades on the 24th. There is also the peak of the Geminids next week on the 14th. Vesta will be at opposition on the 21st. And the longest night of the year is on the following night, with solstice on the 22nd. There are also 2 double shadow transits on Jupiter at month's end, one for Europe and Africa, and one that favors Toronto and points east. In addition to those highlights, here are some important benefits of observing in December. For example, there's early starts, very long nights, which means we can catch constellations from 3 seasons. The ecliptic is at its highest at night, and that's going to benefit Jupiter, bringing up higher in the sky. And if we ever get rid of the clouds around this area where I am, the dry winter air should translate into transparent skies. And there's one other important benefit of observing in December: there are no mosquitoes. Now, I'd like to include astronomical twilight with night in what I call the observing window, since the planets and bright deep space targets can be observed during astronomical twilight when the sun is at least 12 degrees below the horizon. Now, the window is wide open with 11 and a half hours of night throughout the month. And there's another hour and 10 you can add to that if you want to include astronomical twilight, when the brighter deep space targets and, of course, the planets will be available. Dark skies with little or no moon interference begins tonight with the last quarter moon, which doesn't rise until 1:43 tomorrow morning. And that's leading to new moon on the 12th and the first quarter moon on the 19th. And that gives us deep sky weekends on the 9th, 10th, and the 16th and 17th. The full cold moon lights up the sky between Christmas and New Year's, which adds its beauty to the scene at a time when many of us may be too preoccupied with festivities to do stargazing anyways. So I think the moon picked a good time to rise full on Christmas night. Now let's begin our tour of the night sky with a look at the inner solar system. Mercury during December will swing from east of the sun, briefly visible in the west after sunset, to west of the sun by New Year's, visible in the east before sunrise. Venus spends the month west of the sun as the morning star, and Mars is lost in the sun's glare this December, rising just 50 minutes before the sun by New Year's. It will take months before Mars becomes a reasonable target again. Mercury passed through the greatest elongation east of the sun just days ago. Unfortunately, the ecliptic runs shallow in the evenings near winter solstice, so the little planet is just a few degrees above the horizon after sunset and getting lower each evening. It will pass between Earth and the sun mid-month. And maybe we can catch it rising ahead of the sunrise in the east by New Year's, as suggested here. A much better chance for observing Mercury will be in March, in the evening, when it will be 16 degrees high at sunset. Venus continues as our morning star through December. We'll see it dropping lower each morning. It's on its way behind the sun. The planet has a high albedo of 77% and shines around -4 in magnitude, or -3 due to atmospheric extinction when it gets lower. Here's what Venus would have looked like this morning. With high magnification and steady seeing, you might be able to detect its gibbous phase. Now, as for the outer solar system planets, those giants will be in the south as the sky darkens. Many of our fall favorites will still be visible because of the early sunsets, like Aquarius and Pegasus, flying upside down high overhead. At the start of night, we have Saturn, Neptune, Jupiter, and Uranus lined up, west to east. Catch Saturn right away. It will set in just a few hours, and you'll want to observe it before it gets any lower. If you get above average or excellent seeing, you might catch a glimpse of the Cassini division or or Saturn's shadow on the rings. Saturn's rings are tilted only 10 degrees now. We will cross the ring plane in March of 2025. Jupiter still rides high, only a month since opposition, and is getting a boost from the high nighttime ecliptic near solstice in December. It is nearly 47 arc seconds wide and brilliant, with magnitude around -2.7 or a little less through 1.45 air masses. The giant will be due south at 9:20 this coming weekend and visible for 10 hours, which is how long Jupiter takes to rotate. Uranus and Neptune round out the outer solar system giants. Uranus just passed opposition last month as well, and is bright enough to be spotted by eyes alone on a night with above average or excellent transparency. Use binoculars to locate Uranus, which you can't mistake as a star because of its blue color and a disk shape. Once you've memorized a couple of nearby stars, drop the binos without moving your eyes and see if you can spot the blue dot. It's doable. Neptune will require binos or a telescope, however. It's the only planet that cannot be seen by naked eye. It also has a blue tint and a tiny disk, just a couple of arc seconds wide. Now, while we're in the vicinity, high in the southeast, about 20 degrees northwest of Jupiter, is the Triangulum galaxy, M33, sometimes overlooked with the Andromeda galaxy right next door. You can find the face-on spiral about 1/3 of the way between Alpha Trianguli and Sigma Piscium. Messier 33, also known as NGC 598, is home to 40 billion stars. And that makes it the third largest member of the local group after our Milky Way with 200 to 400 billion stars, and Andromeda galaxy pegged at 1 trillion. M33 is 3 million light years away, putting it slightly behind M31 from our viewpoint. Those two galaxies are merging. Andromeda has pulled a long trail of stars out of M33, and that trail now extends between them. Andromeda will completely swallow M33 in about 2 billion years, just prior to Andromeda's merger with our Milky Way, so we're all coming together. The galaxy's disk is inclined by 54 degrees, giving us a good view of its loose spiral arms emerging from the center without a bar. There is no bulge in the center. Large amateur scopes and astro images will show numerous H2 regions, which have NGC designations, and possibly some globular clusters. These are massive O-class and intensely hot Wolf Rayet stars that are triggering the H2 emissions. Now, this is a good time to observe M33, sitting just 15 degrees from the zenith early in the night. Observing the outer planets and M33 will give Orion and the Gemini twins a chance to rise in the east. Here's the scene around 9:15 with the Perseus arm of the Milky Way peppered with open clusters, rising up from Monoceros and passing through the feet of the Gemini twins, Orion's raised arm, and Auriga. There are so many targets, so where to begin? Well, let's begin at the horizon and pick out a few targets on our way up. We start with the seasonal favorite, NGC 2264, which is the designation for two objects, the Christmas tree cluster and the Cone Nebula. You will find this duo about 4 degrees southeast of Xi Geminorum, the eastern foot of Pollux. The cluster is naked eye bright and a great binocular target, stretching 20 arc minutes in height. The tree is lit up with massive OB stars, making the cluster especially luminous from over 2,000 light years away, compared with the Pleiades, which is just 440 light years distant. The Cone Nebula is a massive dust and gas cloud sculpted by the stellar winds from the Christmas tree stars and silhouetted by the H2 region behind it. It may be old hat, but it's difficult to overlook the Orion Nebula, and I hope you'll forgive me for making a stop here. When observing M42 in Orion's sword, you'll also see M43, the comma-shaped emission nebula sitting alongside. This is the closest star-forming region to Earth at 1,350 light years away. Now, with significant magnification, you can split the 4 stars of the trapezium cluster in the heart of the Orion Nebula, and it was first discovered by Galileo. With 125 millimeter or larger telescopes, you may resolve up to 6 stars. Many of these stars are spectroscopic binaries. Collectively, their winds have blown a hole in the molecular cloud from where they were born, allowing us to peer in. Research astronomers are studying these newborn stars and the infrared signatures of protoplanetary disks surrounding them. These may be the newest stars you'll ever observe, estimated to be only 300,000 light years old. OB stars live for only several million years, like 5 or 10, before they blow. M43, discovered by the French scientist Jean-Jacques Autors du Marion around 1730, is illuminated by O-class spectroscopic binary star, the one right here, the hottest of the main sequence stars. And the M42 and 43 components are members of the same molecular cloud, separated by a dust lane known as the M43 dark lane here. And together, these clouds are part of the much larger Orion molecular cloud complex, which stretches the length of the host constellation. Next on our tour is a trio of bright open clusters in the southern half of Auriga that are often referenced together. Charles Messier added the trio of M36, 37, and 38 to his catalog in 1764, but the trio of clusters were first discovered 100 years earlier in 1654 by Giovanni Battista Hodierna using a simple Galilean telescope operating at only 20x. The clusters were then independently rediscovered a century later by Guillaume de Gentil and Messier for inclusion in Messier's catalog. Now, according to Robert Trumpler's classification for open clusters, he considered M37 to be strongly concentrated. That's the Roman numeral 1 here, meaning strongly concentrated. And he considered M36 to be not quite so concentrated, although it does look pretty tight to me. So he assigned it Roman numeral 2, and the least of the three in terms of concentration would be M38, this fellow here, with classification 3. And all of these 3 clusters, they're at the same distance from us. The first 2 are 4,240 light years away, and M37 a bit further at 4511. The stars of M38 add up to a magnitude of 6.4, whereas M36 at the same distance is 35% brighter because it has a lot of bright stars in its core. Brighter still is M37. Its magnitude 5.6 because it's very rich. It's got like 500 stars in it, many of them quite bright. And it's convenient that these three clusters are right next to each other, so it's easy to go back and forth between them to compare their differences. All right. Continuing our climb up into the eastern sky, we reach Beta Persei, known as Algol, the demon star. The star has been despised for millennia by the ancients because it visibly dims by 75% every 2.86 days, from a bright 2.1 to a noticeably dimmer magnitude 3.4. And that happens in a matter of hours. Excuse me. Since all stars were considered unchanging, everlasting, and perfect like divinity, the pulsing of Algol's light was considered wrong and evil, and depicted, for example, as the head of Medusa in Greco-Roman mythology. Algol is a bright binary star with its orbital plane almost perfectly on our line of sight. Larger but dimmer Algol B blocks most of the light from A when it passes in front, causing the noticeable drop in light. There is a secondary dip when B goes behind A, but we cannot notice that one visually. Perseus rides high in the sky in winter, so there will be opportunities to watch it dim or re-brighten over the course of an observing session. There will be an excellent opportunity on Thursday, December the 14th in the Eastern time zone. Mid-eclipse occurs around 9:30 that night, which means you can watch it beginning to dim at the start of nightfall at 6:30, or you can watch it re-brighten around 10:30 if you are out late that night. Now, there is a comet well placed for observing from the northern hemisphere this month. It's comet 62P Tsushinshan, which glides through Leo in December. Leo will be rising around or before midnight over the next month, which puts the comet 56 degrees away from the sun and easy to follow. The comet is not expected to reach naked eye visibility. The most optimistic estimate I saw said it would reach magnitude 8 at perigee in mid-January, so it's not naked eye bright, but an easy target for binoculars and cameras. The comet has a 6.18-year period that has its perihelion point just outside Earth's orbit. In other words, it comes closer to Earth than it does to the sun. We will have ringside seats for 62P's next pass as it reaches perigee in mid-January at a distance of only 0.4 AU. Turning our attention to the sun now, there was a large coronal hole on the sun that was Earth-facing last Saturday and through which strong solar winds escaped, reaching Earth 2 days ago. And as the hole rotates away, we can see magnificent loops and prominences around the sun's limb and bright active regions that rotate into view. The active regions are progressing closer to the sun's equator, and that's a sign that solar cycle 25 is approaching sunspot maximum. The monthly sunspot counts for the current cycle have matched the predictions made by a team led by Scott McIntosh, an astrophysicist at the U.S. National Center for Atmospheric Research. His technique involved up to 4 magnetic bands rotating below the sun's surface that he says were going to align, at least to some extent, and that would strengthen the sunspot activity and cause it to peak a year earlier than those predicted by the NOAA NASA team. McIntosh says it will predict around April in 2024, and that would be right in time for the total solar eclipse. Imagine the huge, wide, large reaching wild corona stretching in all directions around the black disk of the moon. That should be awesome. And speaking of the moon, here we see its phases and libration for the rest of December. Perigee will be on the 16th with the moon a young crescent. The southeast limb of the full moon tilts her way at month's end. And on January 1st, the moon is at apogee, appearing about 9% smaller than it did at perigee. On Saturday, December 16, a 4-day-old crescent moon is available for observing for a few hours after sunset. And this is an opportunity to explore differences between the gang of 4 craters, Langrenus, Vendelinus, Petavius, and Furnarius, that are not far from the moon's south to southeast limb. The 4 craters range from 125 to 177 kilometers in width, and 2 of the 4, Langrenus and Petavius, have well-defined sharp terraced walls and significant central peaks, while Vendelinus and Furnarius are heavily worn and without central features. Now, if you can catch this gang of 4 the night before, on Friday the 13th, the terminator will be much closer to them, and the central peaks in Langrenus and Petavius will cast long shadows, helping them to stand out. Let's have a look at the December highlights now. This coming Saturday morning in the east, there will be a lovely pairing of the gibbous Venus and an old crescent moon. The Geminid meteor shower peaks on Thursday morning, December 14. The Geminids have become the best meteor shower of the year with a predicted zenith hourly rate of 120 under ideal conditions. And that surpasses the popular Perseids of August. This year, a 1-day-old moon sets during twilight on Wednesday the 13th before the radiant next to Castor even has a chance to rise. So there will be no moon interference all night long. And that's perfect. The peak happens as the radiant transits the meridian around 2:30 local time in all time zones. Now, the Geminids are unusual in a couple of ways. First, the Geminids only became an observable shower in the early 1680s. In the early 1860s, with a ZH hour of only 14 or so, plus the occasional fireballs. Now, the rate steadily grew throughout the 20th century, up to 50 by 1930, 60 10 years later, 80 by century's end, and now predicted to exceed well over 100. Now, the second oddity is the influence Jupiter's having on the Geminids. Jupiter's pulling on the stream, causing it to sweep past Earth's orbit, accounting for the ZHR climbing since the 1860s, when Earth first crossed it. The sweeping outward pull by Jupiter will continue on the stream until Earth no longer crosses it in about 80 years, and the Geminids will end. The orbital path of the Geminids crosses Mercury's orbit and reaches out beyond Mars, crossing Earth's orbit, where we pass through in December. Astronomers searched for a comet in this path without luck, until finally an asteroid or an extinct comet was discovered in 1983 using images taken by the infrared IRIS satellite. This is an image taken by the Arecibo observatory that we've lost. Now, the orbital elements are the same as the Geminids meteor stream. So Pantheon was determined to be the parent body of the Geminids. But mysteries remain. Observation by the stereo spacecraft during perihelion showed that Phaethon brightening and producing a tail, but there is very little dust in the tail. It's mostly vaporized sodium gas. The particles we currently pass through must have been produced in some breakup in the past, but it's really just a mystery at the moment. The Japanese Space Agency is planning Destiny Plus, a mission to send a dust analyzing spacecraft to fly by the rock comet, with launch in 2025 and fly by within 500 kilometers of Phaethon 4 years later. The spacecraft will have a dust analyzer, a telescopic camera, and a multi-band camera, and maybe it'll help answer some of the riddles. On Sunday, December 17th, Saturn sits 2.5 degrees north of the crescent moon. 2 nights later, Neptune comes within 1.3 degrees of the moon for observers in Asia-Pacific region, that is. By the time the duo are visible from Toronto, the separation will have grown to 5 degrees. Asteroid 4 Vesta reaches opposition on Thursday, the 21st. It can be found 1/3 of a degree east-northeast of Chi 1 Orionis, at the top of the Hunter's Raised Club. Just at or below the cusp of naked eye visibility, Vesta will be easy to spot in binos or a telescope. You could monitor its retrograde movement against the background stars throughout the night. The moon drifts within 3 degrees of Jupiter on the night of Friday, December 22nd, again favoring our astronomy friends in Asia Pacific. The two will be twice as far by the time they rise over Toronto, twice as far apart. There will be a double shadow transit across Jupiter visible from Europe and Africa on Saturday night, December 23rd. Ganymede's shadow will be a large smudge near Jupiter's south pole, while Europa's sharper shadow will transit across a brighter band and should be more easily seen. Here we see it popping onto the brighter band. And that might be easier to spot than Ganymede's shadow. Early in the morning on Sunday, December 24, a nearly full moon glides within a degree of the Pleiades and should make for a sparkling scene. You may want to try a moon filter to help give the stars of the Pleiades a chance to shine through the glare. And 1 week after Ganymede and Europa cast their shadows together on Jupiter, they do it again. This time it favors observers in Toronto and east. Further west, and there will be more twilight to deal with at the start, but it's still worth a try. The two shadows transit side by side as the sky darkens, and there's a bonus too. Just as Europa's shadow is about to leave Jupiter's cloud tops, Io reemerges from Jupiter's own shadow on the other side and pops into view and back into the sunlight. In real time, you can watch Io grow from a pinprick of light to its full illumination over a couple of minutes. And that's all I've got for tonight. Are there any questions?
Well, first of all, thank you very much, Arnold, for a very thorough and enjoyable presentation about the sky this month. You have some fabulous graphics there. You'll have to tell us where we can find all that one day.
Well, those are my trade secrets.
Indeed.